Hello friends and welcome once again to mathematics video lecture series. We were discussing complex number and I was telling you the cube roots of unity, and we were discussing the general properties of cube roots. So let's continue from there. The last property that I told you was that omega can be written as 1 upon omega square and omega square can be written as 1 upon omega. Okay, so let's go to the next property. I think this was the fourth property. The conjugate of omega is equal to omega square. So this is very interesting. Omega and omega square can be combined, can interact with each other in so many different ways. The product of omega and omega square is 1. Omega is 1 upon omega square. Omega square is equal to 1 upon omega. The square of omega is the third root of cubic root of 1, and now the conjugate of omega gives you omega square. So you can check also, omega was minus half plus root 3 iota upon 2. So conjugate of omega will be minus half minus root 3 iota upon 2. This is nothing but omega square. Similarly, conjugate of omega square will be omega. Okay, this is the very important property. Let's get to the next property. If you remember, I told you omega cube is equal to 1. What if I ask you what will be omega to the power 6? So it's very simple. Omega to the power 6 is nothing but omega cube whole square, and omega cube is equal to 1, so 1 square is again 1. Similarly, omega to the power 9 will be omega cube whole cube, again 1. Basically the point is that whatever power it is, if it is a multiple of 3, then the answer will be 1. So I can generalize it that omega to the power 3n is equal to 1 if n is a natural number. Okay. Further, suppose I ask you what is omega to the power 4. What will be omega to the power 4? So I can write it as omega cube into omega, and omega cube is nothing but 1. So this is omega. Okay, very simple. Similarly, if I ask you what is omega to the power 5, so this will be, there are two ways. I can write it as omega to the power 4 into omega, and omega to the power 4 is nothing but omega, so omega into omega is omega square. Or I can say that omega to the power 5 will be omega cube into omega square, and again omega cube is equal to 1, so this is omega square. Okay, so I can generalize this further. I can say omega to the power 3n plus 1 is equal to omega, because omega to the power 3n plus 1 can be written as omega to the power 3n into omega, and omega to the power 3n is 1, so this is omega. Similarly, omega to the power 3n plus 2 is equal to omega to the power 3n into omega square. This is 1, so it is omega square. Okay, so these are two important properties. Next, another property is, and it's not specifically a property of omega, but we often use it, and that is, what is the cube root of minus 1? Okay, what is the cube root of minus 1? So suppose z cube is equal to minus 1, where z is the cube root of minus 1. So one of the answers you can intuitively get. If z is equal to, obviously you can solve it, you can write it as z cube plus 1 is equal to 0 and expand it as a cube plus b cube. You will get a quadratic and a linear function, and you can find the answer. But I am not doing that. You can try it. I am doing it by hit and trial method. Okay, so if z I keep as minus 1, z cube will be minus 1. So z is equal to minus 1 is one of the roots of the expression. Okay, what about the other roots? Just think about it. If I say z is equal to minus omega and I put this here, I will get minus omega whole cube, which is nothing but minus 1 whole cube into omega cube, and minus 1 whole cube is minus 1, and omega cube is equal to 1. So this is minus 1. So z is equal to minus omega also satisfy the equation. So what is the other root? So one root is minus 1, other root is minus omega. Similarly, what will be the third root? You might have guessed by now. If I put z is equal to minus omega square, then z cube will be minus omega square whole cube. So minus omega to the power 6. This is again nothing but minus 1. So what is the third root? Minus omega square. So what are the three roots of minus 1? Three roots are minus 1. Three roots are minus 1, minus omega, and minus omega square. Okay, so these are some of the general properties that we use when we are dealing with problems of cube roots of unity. Okay, so in the next video lecture I will be starting a new topic, and again, if there is any doubt, please let me know, comment, and if there is any topic on which you want me to make the video, please let me know. Okay, thanks for watching and stay tuned. Have a nice day.